Well, hello everybody, and welcome to another video from the Canal Sidings Model Railway channel. Hopefully this won't be a long video like the last one was, but it will be a bit rough and ready because I haven't really done anything that is mind-blowing. Bit of progress here and there, but not very much. So let's get on with the video. What you're looking at here is the end of my baseboard. There's a little bit of foam still on show down there, which I haven't covered with caulk yet, and the bit that goes off to the right side over there is the original layout, and this is where it joins the new layout, the new part of the layout. And I've been playing with the track plan along here. So what you see at the back there, very badly and roughly laid out, are the three main lines. The top one, the furthest one away, which is that one there, is the up main going south to London. As up and down always goes that way. The next one is the down main, and the last one is the relief, which is a bi-directional line and will be signalled as such. Next to this we have the entrance to the yard, which is that point just there, coming off of the relief line. This is just a safety head shunt for when the points are set against it, so that nothing can roll out onto the relief line, because it may well have passenger traffic on it. And then this is a rather rough and ready layout of what I expect to do. And those four tracks coming off those last 2 points way up there will go right off up to the other end into all the mayhem down there, and will form the engineer's yard. At this end, where this track here crosses over, there'll be a short head shunt just there, and this track here will split into four with a couple of curved points there, and go into four tracks for loco storage, and this will become a stabling point, and there'll probably be a couple of fueling points in here as well. I've built all of this up with points that I already had, which is why I didn't bother to buy any points. I bought some track for the job, but I didn't buy any points. Unfortunately, as usually happens, what I find is that I am 1 point short and I can't use anything different. That point there is an SLE 92, I think it is, which is a left hand electrofog small radius pico point, and I need another one to go just there. So I thought, oh well, I'll just go online and get one of those on order. Yeah, on your bike. Sorry, I've just dropped something. There are none to be had anywhere. I'm just getting hold of something here for the next thing I'm going to say. So what I've had to do is improvise. So what I intend to do is build a pico point out of this sleeper strip and some old rail that I've got here that happens to be hanging off the end of a piece of pico track. So it's code 100 rail, etc., which is what I use. I might have been able to buy a code 75 point, although I very much doubt it for up there. But that doesn't really suit me because I need to be able to slide the rail joiners on and off of it, and the code 75 converters just don't allow me to do that. Not enough to what I want to be able to do. So that was really a non-starter. So that's what I've been doing up until now. I spent a couple of hours yesterday sorting this out, and thinking, oh, I'll get it all started. All I can do at the moment is lay that outer main line all the way along. And what I need to do is get these main lines laid so that all the way along there, you can see bits of bridge and stuff, and round that curve at the end that you can see sort of laid in there, way down the end, just can't even see myself there, that will go to the bridge section. And I need to lay that in first to work out where the bridges are going to go exactly. Anyway, that's the first thing that I've been playing with, and as I say, my next job is to make a picot point. So that'll be interesting. I've got one other thing that I've worked on quite considerably in the time that I've been away since the last video, and I'll show you that now. Well, here we are at the workbench, and what you're seeing now is another little project I've been working on. This essentially ties all of the other bits and pieces that I've been working on for about 3 years together. I could have done what I'm doing here with JMRI, but that would have been requiring a specialised interface of some kind, and I found it easier just to build something like this, which is freestanding, and I can reprogram it very easily at any time to do what I want. But what it ties together is something that I was working on as much as 18 months ago now, which was a semi-automatic colour light signalling system using Arduinos, whereby the signals follow the trains. So as a train passes the signal, it goes red. As it passes the next signal, that first signal goes yellow, and so on around the layout. That basically works, and I've also now come up with a method of using the same thing with some modifications, as it turns out now, but using the same thing to do more. One of the things I always wanted it to do was be able to signal bidirectional tracks, and I've figured out that way now, which actually isn't radical, but it's perfectly okay. And those videos are available. I'll try to put links to them in the description if you want to see them. They are they were made quite a long time ago now. But it was always my intention to go further than just signals that follow the trains so it looks authentic, to actually having the possibility of telling a particular track on the layout to actually go into automatic mode. And automatic mode would mean that when a train approached a red signal, it would automatically slow down and stop, and then when the signal changed to either caution or green, it would carry on as if nothing had happened. And in my last video I demonstrated a method of doing this, having talked about methods that I've tried that just didn't work, and I demonstrated a method of doing this, and it comes under the auspices of automatic braking. And I'm not going to go into it now. If you want to know how it works, then look at the other video. But what the other video had in it was a switch that I could switch the braking sections on and off with. Now that needs to be controlled by the signals and by something that says, do you want automatic control on this track or not? So this is what will be replacing the switch. It's a little relay module which has 2 single pole changeover relays, and is isolated. You can drive it directly with an Arduino on these pins here, and the relays are 10 amps DC, up to 30 volts I think it is DC. 10 amps is much more than I need. I did look for a module that had a single relay of dual pole dual throw DP-DT. Couldn't find one at a sensible price. Found them at very high prices. These I think are about £3, but I can't remember. They come from a company called AZ, and I can't remember the rest of the name, but they're on eBay. Sorry, they're on Amazon, and I bought it from Amazon, and they're in this country. Whether they're made in this country I doubt, but they are in this country, and I've bought 10 of them. I need 9, so I bought 10 of them, and I think 10 of them cost me about £6. So there you go. They're about, I think 10 of them cost me £20. Yeah, so they're about £1 each. Well, the relays cost you pretty much that when you buy them on their own, so I wasn't unhappy with that. But this will replace the switch as as demonstrated in the last video, the manual switch. And to drive that, we need various signals. We only want to switch the braking zone on to cause the train to brake if the signal is red, the braking zone is enabled on that track, and the train has passed the braking sensor, which will be one of these kinds of sensors, as you can see on this board, which I'll go into in a minute, which I use for all of my signalling anyway. And you'll see how they work in the other videos if you have a look. Now what we've got here is we have an Arduino, which is there, which is just on a breakout board to make it easy to connect. That's an Arduino Nano, which has got a bespoke program in it. It's driving this LCD, which is 20 characters and 4 lines, which tells you everything about what's going on. And this board here, this breadboard, represents excuse me, I'm losing my voice, represents what's on the layout. So at the moment it's got 2 sensors on it. One of them would be the braking sensor, and would also be connected to the signal controllers to actually allow it to switch the braking on and off by driving this. This will be controlled by the individual signal controllers that control the braking section. Not very easy to understand what I'm saying, I hope, I think, but you know, it will become clear once I get it all working and you can see what's happening. And this sensor would represent the one next to the signal that says the train has passed the signal, so make it red, or whatever else happens, or make it yellow. Sorry, a train has passed the sensor, so turn it to red, and then it will continue through the sequence as the train passes other signals. Look at my first videos to see how that works. That's just 2 sensors, so that would represent 1 signal, 1 braking zone. I have 3 tracks. Each one of those 3 tracks has 3 signals and 3 braking zones. So that's 9 signals and 9 braking zones. And one of the tracks is bidirectional. So that's actually another 3 signals and 3 braking zones. But because the track is bidirectional, then I can get away with a slightly different way of doing it. But that I haven't tried yet. That's my intention to do that soon. The only other thing on here is this little gadget, which is a remote control receiver. It's an infrared receiver, and to go with it I actually bought this, which is an infrared remote control. It has the usual little thingy there, and if I press a button the camera will probably pick it up turning on. I can't see it. If I could get it to focus it'd help. Oh, I'm terrible at this. There you go, you can see it. Okay. You can't see it with the naked eye. Anyway, I can use this to control the switching things on here. Now on that display we have a note of which track. This is the up main, the down main and the relief. Yeah. Then we have a section which is speed, which I'll come back to in a minute. Then we have the direction of that track. Now the up main is fixed in that direction as we will be looking from here to the railway. The down main is fixed in that direction, but the relief is bidirectional. And I can change the direction of the relief with my remote. So it's now facing the other way. And it's back again. And that will send out a signal to all the signal, that will send out a signal, an electronic signal, to all of the colour light signals in the system on that track to say, set yourself up for this direction of travel, or go back to the other method if you go back. So that's a control signal which has to be changeable. I also have the next section which I've called ABC. ABC really stands for asymmetric braking control, which is a much more sophisticated system but much more expensive to implement, and I've just decided to steal the nomenclature and call it ABC. So I've just tried to knock the bench over and call it ABC. And this allows me, these yeses, the Ys, allow me to decide whether it's on or off for the 3 tracks, up, down and relief. At the moment it's on. I can turn them off, in which case it will say no or N. And the last bit here is these 3 areas here allow me to force on the up and down lines. They allow me to force the signals individually to red, in case I decide to want to hold a train up for any other reason. So that is what I can do, and I can do that with the remote as well. That is just something that's a bit of a nicety. I can't do it on the relief because the Arduino has completely run out of I/O. Now, yes, I know somebody is going to immediately say, you could put an I/O expander on there. Want to keep it simple in terms of how much I have to do. There's a lot of wiring here just to get to all these places. So I don't want more electronics stuffed into the box that this has got, so that I can expand the I/O and even have more wires going round. So I decided the relief line will not have the ability to force red signals. My choice. Yes, I know you could use a shift register, a 4094 shift register, 4018 shift register, 74 HCT. Oh, I can't remember what it is. 74 CD 4008. No, can't remember what the number is. Anyway, it's a shift register that you can just use 3 signals. You need clock, data and latch, and you can expand it infinitely that way. Not really wanting to do that because that's a lot more wiring. You've got to put the devices down on a piece of Vero board or make a printed circuit board. I'm trying to keep all this simple and hence reliable. So I'm only wiring between things. The other bit of this is, as we say, this speed column. And what this does is every signal will have a braking zone sensor and a signal sensor. So I've just chosen the 2 that are closest, that the area that is closest to this box where it will be placed on the front of the layout, to measure the speed of the trains as they pass. And what happens is, this is the relief line I've got these connected to, so the relief line is going in that direction, as you can see. So when a train passes that sensor, a timer starts. When it then passes that sensor, the timer stops and it tells you what the speed was. That was 2 feet of track, and that comes out to be 23.9 miles per hour. That's a scale speed in 00, 1 to 76. And if another train passes a little bit faster, then obviously that was at 100 miles an hour. That's actually above line speed. I can go even faster than that if I do it really quick. That was 170 miles an hour. But more likely it's going to be that, followed by that. And that was 36. If I go a little bit faster, 1 and 2 and 3, that was 71 miles an hour. So there you can see it works. There will be, all 3 of those will be in operation, and it will measure the speed of every train that goes past. A useful feature and a nicety at the same time. The useful feature is so that you can actually say, I've set this railway up, I've set this section of the railway up to be a certain speed limit, and I can actually see how fast the trains have to go to see that speed limit. It has another useful feature as well to do with the braking zone, because when a train reaches the braking zone and it gets turned on, it will slow down, not according to anything other than its own momentum setting and the speed that it's travelling at. So I need to make sure that the trains that I am running will stop before they pass the signal. So I have to know, and I will be making a table of this. Well, I'll add it to my roster in JMRI actually. For each loco setting, I will have what speed number you need, what speed step number you need on the controller to get certain speeds, and I will probably have 20, 30, 40, 50, 60 miles an hour. I think 60 miles an hour is going to be the fastest that I allow on the railway, because it is quite it's quite curvy and everything, so don't really think you want to go faster than that. Even an HST will be limited to that. I can also then specify at which speed you should set it for automatic braking. Bit of a compromise over asymmetric braking control, which will allow you to do it in the decoder, and apparently you specify stopping distance somehow. Don't know how, because I haven't read how they work. But that's where I am now on this. So that's another little Arduino circuit, which will be just packaged up in a box without this bit. All these will be connected to it. And without this bit, that piece will be in another box, and there will be probably 3 of them to a box, because the sections are in 3s and they're distributed around the layout. So there'll probably be 3 of these boxes with 3 of those switches in, and they will be switched by the signal out of here saying, is the section set for automatic braking? And then that will go into the signal controller Arduinos, all of them on that track, and whenever they see a red signal, they will enable the sensor, and as soon as a train passes the sensor, the relays will be switched to make the train stop. When the signal goes back away from red to yellow or green, then the signal controller will drop the relays and say, off you go again, which will switch back. It will drop the relays to say, switch back to normal control, and the train will move. Yeah, this is harder to say than it is actually to see it happening, and you will eventually see it happening, but I haven't got my railway built yet, so you can't. Anyway, I've talked long enough on that. I'll try to leave links to all the videos that I've mentioned in the description, and you can go back and have a look at other things that are described in perhaps a little more detail. I try not to go too technical, but there is the possibility of me doing a full technical article video, or even more than one, once I've got it working, so that you can see all the bits and pieces, and I'll try and show you everything if there's enough interest. And I've mentioned this in my previous video. There needs to be a lot of interest to do it, because it is quite an involved and specialist subject, and a lot of people just won't be interested in how it's done. Oh yes, it's great, but too difficult for me. That's absolutely fine by me. I just like technology. I used to work in electronics, so all of this comes natural to me. Anyway, thanks for watching, and I hope to see you all again soon, or I hope you can see me again soon in the next video, which hopefully won't be too long. Maybe we'll have a bit of track laid, and who knows, we might have a first train running round Inglethwaite New. So bye for now, everybody.